All right, assignment 5.4, antiderivatives. Who knew, right, that you could go the other way? So instead of derivatives, the antiderivative. So I'm going to write these questions down, and we're going to practice writing them calculus friendly. That is with powers that are negative or fractional powers, so we can do rules. And the rule for antiderivative on the whole is to add 1 to the exponent and divide. So it's the anti-rule of the other one, right? So we're going to add 1 to the exponent and divide. All right, so 1 over x cubed dx. The integrand is 1 over x cubed. We're going to write that as x to the negative 3. And then we're going to follow the rule. And the rule is add 1 and divide. So that's what we're going to do. Add 1 to the exponent and divide. And for the antiderivative, we can't forget the candy. Plus c. Number 2. We have an integrand, and we're going to write that as t to the exponent 1/4. Now remember, when we add, when we subtracted, we want top subtract bottom. When we're adding, go bottom, adding the top. Bottom plus the top. So if it's to the exponent 1/4, and you're adding, go 4 plus 1. Go the other way. That's 5 over 4. And then don't forget the candy. Oh, we have to divide. Remember, do it times the reciprocal. It's a great thing to practice. So instead of dividing, go times the reciprocal. Can make things a lot easier. Make sure this is focused in. All right. Feels like it's a little blurry. Maybe it's my eyes. I don't know. So add 1 and divide, and when it's a fraction, go times the reciprocal. Number 3. In number 3, I think we have to multiply it out. Yeah, FOIL. So that would be x squared minus, it's negative 2 plus 1, which is minus 1x. 1 times negative 2 dx. Put parentheses around it, and then just one at a time. See if I can get this thing to focus just a little bit. All right, so one at a time, add 1 and divide. So add 1, divide, add 1 to the exponent and divide. Negative 2 is just negative 2x, the antiderivative of a constant. And then don't forget the candy at the end. That's it. Number 4. For number 4, write it calculus friendly. So, see if I can see this. So to write it calculus friendly, start this way. So it's 2y times y to the negative 1/2, and then do exponent rules to combine it together. So if I do exponent rules, add the exponents together, that's positive 1/2. Now one of the rules to antiderivative is that any constant can be written in front of the integration, if that's helpful. And then when we do the antiderivative, we have 2 in front. I'm going to go 2 times, and we add 1. So 1 plus 2 is 3 over 2. Divide or times the reciprocal. So it's good practice to know this is 4/3 plus c. Number 5. Here we go. We're just moving along here. All right, evaluate the integrate each integral in problems 5 through 13. So 2x cubed subtract x squared plus 1. So we don't have to change anything. Just integrate what you see. So again, add 1 and divide. And we don't have to simplify it. So let me show you what I have. So when you add 1 and divide, so you had 2x cubed. So add 1 and then divide. You don't need to write it as a half. Add 1 and then divide. 1 just becomes 1x, and then the constant. This is something new that you need to be aware of when you integrate. 6. So first thing I look at, I need to write this calculus friendly. So I'm going to write 1/3. I'm actually going to write 1/3 in front of the integration, and then x to the negative 2 dx. dx is essential, a part of the notation that you have to remember when you write it down. So I put 1/3 in front, then x to the negative 2. So we have 1/3, and then do what it says. Add 1 to the exponent and divide, and don't forget the constant. That's a great answer. Yes, the answer could be negative 1/3, or the answer could be with the x in the denominator, right? Because x to the negative 1 means that's where it belongs. So in multiple choice, you have to have the skill to change it with what you need. Number 7. So again, I'm going to write this. 3x squared is 9x squared. So I'm going to have 1/9. And then x to the negative 2. So that's the first thing I do. 1/9 x to the negative 2. So we have 1/9. And then add 1 to the exponent. Be careful when you have a negative number, right? Negative 2 plus 1 is negative 1. And then divide by negative. Just know when you divide by negative, that fraction becomes negative 1/9. And don't forget the candy. Don't forget that constant at the end. Number 8. Write it calculus friendly. So I have 3 subtract. Now, how do I write down the 5th root of y squared? That's y to the exponent 2/5. dy. Then, just each one integrated. So 3 becomes 3y to the 2/5, you add 1. So that means you just go 5 plus 2. So that's 7. And instead of dividing, you go times the reciprocal. Practicing multiplying times the reciprocal will be helpful. And then the constant. Done. Number 9. All right, let's integrate. All of them are ready. So I was just looking to see if I needed to change anything, but they're ready to go. So let's do it. So I'm going to write it down and show you how simple this is. So the rule is to make it calculus friendly. So that's with a negative exponent or a fractional exponent. So we have no fractions or radical signs. And then you add 1 and divide. So add 1 to the exponent and divide. So here, add 1. So 4 plus 1. 4 plus 1 is 5/4. And then instead of dividing, we go times the reciprocal. And yes, we could simplify this down on the next step. Let's do it again. Add 1. So 3 and negative 2, when you add them, is positive 1. Divide or times the reciprocal, and don't forget the constant. And yes, the 5s divide out, so you probably will see it that looks similar like this. Fractional exponents are perfect. You don't need to change that. 10. Here's one that we could FOIL. So 3t minus 10 times 3t minus 10. So FOIL it out, and you get 9t squared. Multiply the two terms together. That's negative 30, and double it. And then 10 squared. That's 100. So it's good to have a quick way to be able to FOIL a binomial squared. There it is, right there. And then each one at a time. So add 1. Now when you divide, you get 3. Add 1. When you divide, you get 30. And then just 100t. And then don't forget the constant. Number 11. In number 11, we're going to simplify it. This is such a classic case where you have a monomial in the denominator. And so to simplify it, that monomial can simplify each term above it. So I'll show you what it looks like. As I write it out. Just making sure I wrote it correctly. Here we go. So that 2x squared can go into each term. So I can simplify it and then do my power rules. So if I simplify this, this is just 4x squared. If I simplify this, it's just 1. If I write this one properly, it's 1/2 x to the negative 2. Now, with that step, just simple integration rules. The antiderivative, you add 1 and divide. 1 is just x. Here, add 1. And it's x to the negative 1 when you add. And when you divide, it actually becomes a plus sign. Plus c. So when you divide by a negative and a negative makes it positive 1/2. X to the negative 1. Number 12. Here we go. The same thing here. So for this one, we're going to take the monomial. You have a term in the denominator. So we're going to divide that to both terms. All right. So here we have that root t divides both terms so that we can then do calculus rules. So root t divided by root t, that's just t. Root t divided by root t is just 2 dt. And notice a negative and a negative would make this plus. And then we're going to write root t as t to the negative 1/2. So 2, the antiderivative is 2t, working backwards. Here, if I add 1, 2 and negative 1. If I go 2 plus negative 1, that's 1/2. And then divide or multiply times the reciprocal. And then the constant. Did I put too many minus signs there? Let me just look here quick. I did. So I put a minus and then another minus. Let me just correct it. So the sign is off just a little. So subtract that. It wasn't a subtract a negative. I just wrote it down properly. So that subtract sign. So that just changes to a subtract sign. 13. Some more algebra to help us out here. So I'm going to write that as y to the 1/2 y squared plus 2y to the 1/2 dy. All right. So I wrote that down so that I can do some exponent rules and then do the calculus rules. So I'm going to distribute, and when I multiply, you add them together. So 1/2 and 2 is 5/2, or 2.5. So add 1/2 and 2, that's 2.5, or 5/2. Add 1/2 and 1/2, and it becomes a whole. So it's just 2y. And now we're ready to integrate this, where we add 1, so 2 plus 5, that's 7/2, and then the reciprocal. And then 2y, you add 1 and divide. So y squared, and then 2 divided by 2 leaves you with 1y squared, and then the constant. All right, number 14. In number 14, you're given the derivative, 3x squared subtract 4x plus 2. You're told f at 1 equals negative 3, and told to find f at x. So let's do this together here. So what we are is that we have a value to find the constant, right? And so if I integrate the derivative, I just get f at x, right? plus the constant. So just be aware of that. So when you integrate a derivative, that's where you get your function that you're looking for. So in other words, can you integrate this? So f at x was going to equal x cubed, right? Divide by 3, that's 1, minus x squared. 4 divided by 2 is 2, and then 2x, and then the constant. Now we're given a value to plug in. So the y value, which is f at x, and then the x value, which is 1. And now solve for c. So this is negative 3. 1 take away 2 plus 2. That's 1. I think it's negative 4. Right? So then you have to put it all together. So what is the function then with c being negative 4? The answer is x cubed subtract 2x squared plus 2x subtract 4. That's the answer. All right, number 15. Next page. The other way. All right, the derivative of a function is dy by dt negative 3 over t squared plus 1. If the graph of the function contains the point 3, 10, find the equation of the function. Let's do that. So for this one, we're going to integrate to find what, and we don't need the dt because it's already there on that side. We're going to integrate both sides to know what y equals. So when you integrate and derivative, that gives you what y equals. They undo each other. For this side, I'm going to write this as negative 3t to the negative 2. You still need that dt there. Now we do the calculus rules. So add 1 to the exponent. So negative 2 plus 1, that's negative 1. And when you divide, that becomes positive 3. A 1 becomes 1t, and then the constant. So there's the function. We have a point to plug in, so the y coordinate is 10. The t coordinate is positive 3. And then do you have the ability to simplify that? So 3 to the negative 1 is 1/3. So in other words, 3 and 1/3 just becomes 1. So if I combine this together, I have 4 subtract 4, and you get c is equal to 6. Then I need to put it all together from here and write down 3t to the negative 1 plus t, and c is 6. And now you have the equation. So you're given the derivative and a point, and you're able to do the antiderivative, plug in the point, and now you can find and work backwards and find what the equation is. Number 16. Number 16, find an equation for the family of functions whose derivative is that. So y prime equals 3 root x. And then go through a particular point. So the first part is you need to go plus c when you do it. So if I integrate that, I get y equals, now remember that this, and this is dx when you do that, this is 3x to the 1/2. There it is. When I do that. So I'm going to add 1 to the exponent. So 2 plus 1 is 3. Then I'm going to go divide, or the reciprocal, and then remember there's still a 3 in front of that. So remember to add 1, divide, or by the reciprocal, and there is a 3 there that needs to be included. The 3's divide out, and it gives you 2 equals 2x to the 3/2 plus c. That is the part A. Part B, you give a point, right? Part B, you're given 4, 0. So if you're given a point, so the family is this, meaning that you could plug in any number for a constant. That shape would just go up or down, whatever the constant is. So that's the family, and you could add or subtract to shift that up or down, whatever needed. Here you're given a point, so y is 0, x is 4, and then can you simplify this to find the constant? So the square root of 4 is 2. 2 cubed is 8. And that's going to be negative 16, right? So it's 16 and then subtract. So if I put it together, it would be y equals x to the 3/2 minus 16. So that's that family. Oh, 2x to the 3/2 minus 16. So that's part B. Number 17. Number 17, you're given the second derivative. 2x subtract 3. You're given the first derivative at 0 equals negative 5. And the function at negative 1 equals 2. And that, can you work backwards with the given information? So I'm starting here. So if I integrate the second derivative, that's equal to the first derivative. Right? So if I integrate the second, it's equal to the first plus a constant. So that's what I'm going to do. So the derivative, or the antiderivative there, would be x squared subtract 3x. So you add 1 to the exponent, that's 2, and divide, you get 1x squared. Negative 3 is just negative 3x, and then the constant. Now we have a value to plug in. So it says g prime at 0 is negative 5. So that's the y coordinate. This is the x coordinate. So it wouldn't take much work here to know that c must equal negative 5. So the derivative then is x squared subtract 3x subtract 5. Now one more time we need to integrate this. So we're going to integrate this. And when we integrate it, we find the function we're looking for. So one more time, we're going to add 1 to the exponent and divide. We're going to add 1 to the exponent and divide. And then negative 5 is negative 5x. And don't forget the constant. We're given that, the y coordinate is 2, and the x coordinate is negative 1. So the x is negative 1 and the y is 2. So plug that in and then solve for c. So I get negative 1/3, negative 3/2, plus 5. Man, a lot of fractions. Not a fan, but I'll do it anyways. Making sure that I'm okay here. So negative 1/3, negative 3 plus 5. All right, let's solve this. So I need common denominators all around. That will make life easier. It's going to be 6. So I'm going to multiply by 6, by 2, by 3, by 6, and I'm going to clean it up. So let me continue on another piece of paper here. So if I did that, it would be 12 over 6. When I multiply it times 2, it would be negative 2 over 6. Times 3 is 9 over 6. And then 30 over 6. So I got all common denominators. So here, if I look again, if I multiply by 6, 6 times 2 is 12 over 6. Negative 2 over 6, 9 over 6, 30 over 6. That's where it comes from. All right, we're going to combine them together. So that's negative 11 and 30. What is that? 19. And then when I subtract, it'll be negative 7. Is that right? Let me just check my answer key. Good. So then when I put it all together, it's g, right? G at x. When I put it all together, I had x cubed over 3 minus 3x squared over 2 minus 5x, and then my constant I found was negative 7 over 6. The awful part was just the fractions at the end, which is not calculus. 18. In 18, it says evaluate. And it says hint, this is that derivative of an integration. So the basic hint is they undo each other. So the answer is just 2x subtract 1 cubed. That's part of the fundamental theorem of calculus, which we're going to learn in the next lesson. So they undo, and you're left with that. Pretty simple. 19. And you might say, hey, where is the constant? Well, the derivative of any constant is 0. So if you integrate this plus c and then take the derivative, that plus c is going to go away and you'll be left with that. Okay, number 19. Acceleration of an object. So we have the acceleration 6t subtract 4. And you're given the initial velocity is 5. And the initial position is negative 2. Let's see what we can do. Find the velocity, and then find the velocity at, well, let's just do one at a time. So let's find the velocity. So the velocity is the antiderivative of 6t subtract 4. So we're going to go t squared. 6 divided by 2 is 3. So it's 3t squared minus 4t plus c. It says the initial velocity is 5. So if I plug in 0 means initial. So plug in 0 for time and then solve for c, you get 5. So the velocity then is 3t squared minus 4t plus 5. In part B, it says find the velocity at 2. So take what you just learned and just plug in 2. I don't think there's any units involved here. I'd have to look again over if there's any units to put in for the velocity. So that is 12, take away 8. That's 4 plus 5, which is 9. Part C says find the position. So I'm going to do I'm integrating the velocity for the position. So when I integrate this, again, I'm adding 1 and dividing. So add 1, t to the 3, divide, that's just t cubed. Here, add 1 and divide, that's 2. And then 5 is just 5t plus c. And again, it says the initial is negative 2. So I'll give you a hint. Whenever it says initial and you plug in 0, that is what c is. C is the initials. Like if you plug in 0, that's the answer you get. So if I plug in the value, I get t cubed subtract 2t squared plus 5t, and then it says the initial is negative 2. So that is what your c is when you plug in. And then in part D, it says, what's the position at 2? So then you plug in 2 and just do the work that you see in front of you. And the answer is 8. All right, there's A, B, C, and D for number 19. Number 20. The velocity of an object moving along a vertical path, that means it's going up and down, is given there. So I'm going to write that down. I'm also going to write it calculus friendly. So t to the 1/2 plus 1 when t is greater than or equal to 0. It says find an equation for the acceleration. So we can't forget that if you know velocity, then acceleration is the derivative of it. So you have to remember, am I doing the derivative or the antiderivative? And think, what's the power rule for each one? So for the acceleration, I'm taking the derivative because I'm given the velocity. So I'm going to do the derivative. So that's 1/2 times 1, subtract 1 to the exponent, and the derivative of 1 is 0. So there's the acceleration. Know when you're doing the derivative or the antiderivative. For B, it says find the acceleration at 9. So you just plug 9 in and solve it. So if you plug 9 in, the square root of 9 is 3, but that negative exponent means reciprocal. So then you multiply across the top and bottom and get 1/6. C, I think, says to find the position. So what's the object's position at t equals 9? Oh, the object's position at t equals 9 is 20. Find an equation for the object's position. So the object's position is the antiderivative of velocity. And I'm just going to write down 920, so I know that I need to plug that in. So the antiderivative here, so that means for the position, you're going to add 1, and then the reciprocal. 1 becomes just 1t, and then the constant. And then you plug this in, 9 and 20. So 20 is the y-coordinate. 9 is the t. And then you solve for c. Fractions everywhere. So the square root of 9 is 3, and 3 cubed is 27. This is 54 over 3. Just keep going. Subtract 9, that's 11. Subtract 54 over 3. So that's 33 over 3. Subtract 54 over 3. So I get common denominators. 11 is 33 over 3. Common denominator, subtract. That's negative 21 over 3, which is negative 7. Is that right? So I got C to equal negative 7 after all of that pain. And it is. Now put it all together. So the position equation is 2/3 t 3/2 plus t minus 7. So from this, you go back to this and then just plug in what C equals. Don't forget to do that. You need to finish the question off doing this. All right, 21. A ball is dropped from a bridge, which is 160 feet above the river. How long will it take the ball to hit the water? And it says use this position equation, negative 16t squared plus the velocity, initial velocity times t plus the initial position, s. All right, so what do we know and what are we looking for to do this? So this is my initial position using it. This is my initial velocity. So let me make sure I understand what's happening. Again, so a ball is dropped from a bridge, which is 160. How long will it hit the water? So if it's just being dropped, the initial velocity is 0. It's not being thrown down, it's just being dropped. So the initial velocity is 0, and the initial position is plus 160. So that's what I have. So again, because it's being dropped, the initial velocity is 0, and S sub 0 is the initial position, which is 160 feet above. And then what does it ask for you to do? When will it hit the water, right? So make it equal to 0, and then solve it. So we're going to subtract 160. We're going to divide. And then when we take the square root, we're only going to have the positive answer. So again, when it hits the water, the position is 0 when it hits the water. So subtract 160 and divide. So it's the square root of 10, and there's your answer, and it's in seconds. So in root 10 seconds, the ball will hit the water. All right, number 22. Oh, I thought that was the last one. Next page. 22. Haha. For the first 4 seconds of a race, a sprinter accelerates at a rate of 3 meters per second squared. He then continues to run at this constant speed that he has attained for the rest of the race. It says write a piecewise function to express the sprinter's velocity as a function of time. So the acceleration let me show you. Oopsie. So the acceleration is 3 for the first 4 seconds, and then constant, which means 0 after that. So it accelerates and then constant, going whatever speed it's going. So there's your piecewise from there. And then it asks, find v at 2, v at 4, and v at 6. So to find the velocity, we're going to do the antiderivative. So for 3, it's 3t. And the antiderivative of 0 is 0. Or is there some more information there? I'm trying to think where they get 12 from. So I'm going to read again. So for the first 4 seconds of a race, a sprinter accelerates at a rate of 3 meters per second. He then continues to run at that constant speed that he has attained for the rest of the race. So the antiderivative is going to be a constant when you're greater than 4. I can figure this out. Okay. I get it. See if I can explain it. So, the antiderivative of 3 is 3t. The runner accelerates to 4 seconds. When I plug 4 in, 3 times 4, the speed at 4 seconds is 12, and that's the speed for the rest of the time. So you say you accelerate for the first 4 seconds. We did the antiderivative. When I plug 4 in, what is that speed at 4 seconds? And he maintains that speed for the rest. And the derivative of 12 is 0, and the derivative of 3t is 3, so it matches. And then it asks a bunch of questions, like, what's the velocity at 2? So between 0 and 4, you plug it into the top, and the answer is 6. And I got to look at the units. Well, it's meters per second. The next one is 4. Well, that's still the top one because it's equal to 4. So that's 12. And we figured that out. And then 6, it maintains that speed. So 12 is the answer all the way through there. So it accelerates up to 12 meters per second and then keeps that speed. So at 2 and at 4 and at 6. Part C. Write a piecewise function to express the sprinter's position. So for the position, again, I do the antiderivative. So that's t squared divided by 2. And there's a 3 there, so it's 3 halves. And the other is 12t. So again, the antiderivative here is t squared divided by 2. That's this. So it's 3t squared divided by 2, and 12, the antiderivative is just 12t. So there is a piecewise function describing position. How far does the sprinter run during the first 4 seconds of the race? So during the first 4 seconds, you would plug in 4 into the top. So the first 4 seconds, to find, that means find the position at 4, plug 4 in. So 4 squared is 16 divided by 2. So 3 times 8, that would be 24 meters in 4 seconds. E. How long will it take the sprinter to run 100 meters? So to run 100 meters, the first 4 seconds is 24 meters. And then there's a constant of going 12t for the rest, whatever that time would take to do that. So we have the first 4 seconds is 24. And then we have 12t to figure out, all right, like that's equal to 100. So subtract 24, and that gives you 76. And so I got 12t equaling 76. So I'm going to subtract 24 to both sides. I get 76 divide. That does go in evenly, right? Doesn't it? No, it doesn't. 6 something. So how long does it take? So make sure. So the first one, this is 4 seconds. And then the question is, how long does it take to go 76 seconds? Right? Or 76 meters. This took 4 seconds. How many does it take to go 76? So it adds up to 100. So that's 76 divided by 12. And those are the two you put together. So 12 goes into 76. 6 times, that's 72 and a little bit more, right? So that's 4 over 12. So if I add them together, 4 and 6, all together, that would be 10 and 4 twelfths, 1/3. So altogether, it would take 10 seconds. For the first 24 meters, it took 4 seconds. There are 76 meters left. Divide, that's the rate, 12t. Divide by 12. So for the last 76, it would take 6 and a little bit. Put it together, and you get 10 and 1/3 seconds. All right, that's a great thinking person question for sure to go through. 23. I'm just going to finish this off. So these, I think, are review questions. Let's see how we do. So for these problems, the graph of the derivative is given. Sketch a graph of the function. I love these. So this is all about solving a puzzle. So the derivative is a constant at 2. And what I wanted, and it contains the point 0, 1. So what does the function look like? So the first derivative line is always positive and always positive 2. So it's always increasing. And it's always positive 2. The antiderivative of that is 2x. In other words, you're going to graph y equals 2x. Oh, and it contains the point 0, 1. So start at 0, 1. So it's 2x plus 1 because it contains this point. So start at 1 and go up 2 and over 1. And there's the equation of the function. See, this describes the slope being 2 everywhere. The slope being 2 everywhere, and you start at 0, 1, and there it is, and there's the equation. Man, it just all fit together. 24. Oop. Let's try this. 24. Again, you're given the derivative. So what I'm going to do is do a number line for the first derivative. What's the x-intercepts? -1 and +1. Those are my critical numbers. And is there anywhere where the derivative's undefined? No, it's continuous. It's below, that's negative, and then -1, and then above, and then below. So it's negative, positive, negative. And it says start at 0, 1 again. Now, I kind of know what that graph is. So the derivative is a parabola, and it's been shifted up 1. So it's really x squared plus 1. That might be helpful to see, right? So it's a parabola, and in fact, sorry, it's negative x squared plus 1. So it's a parabola that's been shifted up 1, but it's folded down. So you have negative x squared plus 1. If I did the antiderivative there, you would add 1 and divide and have that constant. So add 1 and divide. The antiderivative of 1 is x, and the constant. We have 0, 1, so that means c is 1 when you plug in 0 for x. And so that's what we're graphing. So if I start at 1, at 0, 1, so what do we know at 1? We know at 1 is, so 0, 1. So at 1 is a maximum. At negative 1 is a minimum. So if I use this as a guide, if I use negative 1, so what's f at 1? That's negative 1/3 plus 1 plus 1. That's like 2, a little less than 2. So there's the maximum. If I plugged in negative 1, so if I plugged in negative 1, you can end up with a negative positive 1/3. So this is actually just a little bit above. So negative 1 and just a little bit above, right? And if I cared about the concavity, I could also do a second derivative number line. So if I look at the picture again, what's the second derivative? What are the critical numbers? Is there a turning point? So there's a turning point at 0, right? And that's it. And then it increases and then it decreases at the turning points. That's a point of inflection. So at 0, we have a point of inflection, and it's concave up and then concave down. So understand what's happening here. So we're going to go decreasing with a smile. So we're going to decrease with a smile, but it turns at negative 1 because we have a minimum. After 0, it's going to frown, but again, it's going to frown and then put all the pieces together. So it decreases, then it increases, then it decreases. So we have our minimum and our maximums correct. It smiles, and then it frowns, and we have our concavity correct, and we put it together. All right, 26, we're almost there. 25, we're almost there. 26 would be even closer. 25, list the domain, all kinds of good stuff, and then sketch it. So here we go. Y equals x squared subtract x squared minus 1. Let's do this one together. Great practice. So we're going to do pre-calculus, then we'll do calculus. So first I'm going to factor. Then I'm going to list the domain. So I know that x cannot equal positive and negative 1. That means, and there's nothing removable, so both of those are vertical asymptotes. The intercepts, we have an x-intercept at 0, and it's even, so it just touches. That's also the y-intercept as well, when you plug in 0. What else are we looking at before? The end behavior. So if I go power divided by power, x squared divided by x squared, it's y equals 1. So the limit as x approaches infinity of f at x, if we call that, or y, is equal to 1, both directions. So the left and the right end behavior is 1. So that right there is our horizontal asymptote. So let's see what we have so far. So far we have y equals 1. And we have x equals 1 and negative 1. And we have an intercept at 0. Right there. So that's what we know so far using pre-calculus. Now for calculus, we need to take the derivative. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. So if I just take the numerator, and multiply it out, equal to 0, notice we have 2x cubed and minus 2x cubed that eliminate. So when I solve it, 0 is my only candidate for a turning point. So I'm going to see increasing and decreasing. Notice the denominator is still -1 and +1. That makes the bottom 0. But these are asymptotes. So they can't be extreme point. So only 0 can be that extreme point. So if I rewrite the derivative again, it'd be -2x over x squared minus 1 squared. That's the derivative. If I plug in a negative number less than -1, you're going to end up with a positive answer. If you plug in -1/2, you'll end up with a positive answer. If you plug in +1/2, it'll be a negative answer, and then on the other side negative. So it's positive, concave up, and then here, what's happening at 0? So at the first stage, it goes increasing, and then at 0 creates that maximum. So at 0, 0 is a maximum. Now I know the direction of this, so I'm not even going to worry about the second derivative. That's a maximum right there. And I know the direction in terms of what the other ones are going to look like. So it increases and then decreases. So increases and so on. You can see concavity here too. Concave up, concave down, concave up. And you can tell the concavity by the asymptotes as well. So I didn't need the second derivative. I could tell the concavity, the asymptotes led to the concavity. All right, 26. So in 26, you're given a function, and you're asked to find the inverse of that function. That's what that little -1 is. Don't think that's the derivative. So let's do that. So that means x equals, and I solve for this. Boom. So I'm asked to find the inverse, which is that little -1. So don't confuse that with the derivative. And now get y by itself. So multiply by 2. Do the cube to both sides. And then add 3. And that is the inverse. 8x cubed plus 3. Make sure I did it right. Yep. All right. 27. We're almost there. You know, you don't have to do this all in one sitting. You can take your turn, take your time, do like 30 minutes at a time. All right. Find an equation of a line tangent to y equals x to the 2/3. Parallel to 2x subtract 6y equals 5. The word tangent means derivative. Parallel means the same slope. Let's go. I'll show you what we're going to do. So I need to take that derivative. That's what tangent means. That's 2/3 x subtract 1. And I need to know the slope here. So I'm going to subtract 2x and divide. So when I divide by -6, really all I cared about was this right here, the slope, which is 1/3. So divide, what parallel means the same slope. So take the derivative, make it equal to 1/3. And now you're going to solve this for x. So multiply by the reciprocal, which is 3/2. That gets rid of the fraction. We got 1/2 here. Recognize that a negative exponent means the reciprocal. That's the cube root of x. Sometimes it's easier to write it non-calculus-like to solve the algebra. Notice the numerators are the same, so I can just make the denominators equal to each other and then cube both sides and you got what x equals. Now it says both the x and the y. So it says the point. So we have 8. So what point? We have what x equals. To know what y equals, it's 8 to the 2/3. So you go back and say, oh, what does y equal then? Well, 8 to the 2/3. What does that mean? The cube root of 8 is 2, and 2 squared is 4. So the point is at 8, 4, where that's happening. We have, and then it says, wait, make sure I answer the question. It said find an equation of a line tangent. So I need an equation of a line with that. So x equals 8, y equals 4. The slope, we knew right at the beginning, was 1/3. That was right there, right? We knew right away we made it equal to 1/3. So the slope was 1/3. We found x, we found y. What's the equation then that comes from that? So it's y equals the slope, change the sign, keep the sign, and you have the equation of the tangent line that matches that. All right, 28. I think it's the last one. It is. Find the cubic function of that form which has a relative maximum at 0, 2 and a point of inflection at -1, -2. So I'm going to write it down. And it's going to be a system that we're going to create. So we know a point 0, 2 is a max. And we know -1, -2 is a point of inflection. Okay. So first of all, regardless if it's a max or a point of inflection, we have 2 points to plug in. So first, I'm going to plug in 2 for y. And if I plug in 0 for x, d already is equal to 2. Just by plugging in 0, 2. So I can write y equals ax cubed plus bx squared plus cx plus 2. So I already know it's equal to 2. Next, plug in the second point that I know, -1, -2. That's -2. And then -1. And then I'm going to simplify this. So I have -2, -a, plus b, minus c, plus 2. Subtract 2 to the other side. And now you have an equation to at least deal with. So you have -4 equals -a plus b minus c is equal to -4. All right, now we're going to deal with the fact that this is a maximum. So I'm going to come back here. Maximum means if you take the derivative at 0, the answer should be 0. So when you take the derivative at 0, the answer needs to be 0 for it to be a critical number and a maximum. So we're going to take the derivative. That's 3a x squared plus 2bx plus c. The derivative of 2 is 0. So when I plug this in, so when I plug in 0, the answer has to be 0. So if I do all that, c is equal to 0. Now the next derivative after that. So now I already have two variables, two things down. So right now I know -4 is equal to -a plus b, because that c is 0. So now I reduce this down. I have two more variables. I need to take the derivative of this to get the second derivative. So that's 6ax plus 2b, and the derivative of c is 0. And again, if this is a point of inflection, when you plug in -1, the second derivative should be 0. So when I plug in -1, the answer should be 0. So I'm going to plug -1 in. The answer should be 0 for the second derivative. It's a point of inflection. So I have -6a minus 2. So now I can solve for a. So add 2 to the other side. Divide. So you get a is equal to -1/3. Let me make sure I did that one right. Let me make sure. What did I do wrong here? So 6ax plus 2b, plug in, there's no x to plug in there. That was just a b. So I have negative 6a plus 2b is equal to 0. Ignore this. Now we can come back here. So 0 is equal to negative 6a plus 2b. Now I have two equations, two unknowns. So I'm going to multiply the top one times 2 and then subtract and then divide. So if I multiply it times 2 and subtract, I get positive 8. Negative 6 subtract negative 2, that's positive 4a, and they eliminate. Divide, I now will know what a is. A is equal to 2. Then we can go back and solve for b. And if you add 2 to the other side, b is negative 2. Alright, so let's make sure I did all the little math correct here. So I'm looking at the answer key as I look back at u. So negative 4. So we have negative 6a plus 2b. I got that, equals 0. And the other one was negative 4 is equal to negative a plus b, right? So negative a plus b is equal to negative 4. Make sure I did this one right. That's what I had, right? So if I'm, how about if I tried a different way? The answer key shows something else, but let's see. If I multiply by negative 2, I get positive 2a, negative 2b, and positive 8. So I get negative 4a, divide, I still get, I get negative 2 this time. So I get a equaling negative 2 by going this way. So what did I do wrong over here? So when I multiplied the bottom, the top times 2, and then I subtracted, negative 6 plus 2 is negative 4a. There you go. So there's the mistake. So this should be positive 2, which makes that negative 6. So then this should be positive 2. So a is negative 2, but if you plug it in here, a negative and a negative makes it positive 2. So now I have the values. I'm just going to put it all together now. So a is negative 2, b is negative 6, c is 0, and d, we said, was 2. So the equation then would be, because that's the whole idea, is put it all into the equation, was negative 2x cubed minus 6x squared, 0x, and then plus 2. That's putting in A, B, C, and D. There it is. A, B, C, and D. Back to the beginning. And that function, what we just wrote, this has a maximum at 0, 2, and a point of inflection at negative 1, negative 2. And we did that doing algebra working backwards. I'm so proud of you. You got through this. Mr. G Math over and out, and until next time.